The real figure is something like this. There are 3 rods over here. This one is the bigger rod. These are the 2 smaller rods. Delta L2, what is happening? Compression, negative sign. So you need to put a negative sign over here and all of this. Hello everyone, this is Manas, your friend and tutor. And guys, today's session, we're going to be talking about statically indeterminate system, and we'll sort of solve 2 problems based on this category. Now, some of you guys might be wondering, this looks like a very heavy term, very fancy term. Just listen to this very carefully. If there is a system which comprises of, let's say, 2 or more than 2 members of different materials, let's say aluminum, steel, brass, copper, anything. In such a case, equations of static alone are not enough to get you the value of unknown forces along, say, copper, along, say, steel, right? In that case, the deformation of those bars also have to be taken into account using formulas such as delta L is equal to PL over AE. So basically what I'm trying to say is, as far as statically indeterminate systems is concerned, just listen to this very carefully. The arrangement comprises of different members, 2 or more members having different materials, say aluminum, copper, steel. In that case, using equations of statics alone is not enough. What are equations of statics? Summation of all the forces along x, say y or z direction is equal to 0. Also moment also about a specific point on a plane of forces is equal to 0. These equations are not enough to find the value of unknown forces. Let's say force along steel, force along copper, or force along aluminum, right? If you want to work out the forces of along these 3 different materials, it has to be supplemented. It has to be supplemented with this deformation formula, and this is exactly which fills the criteria of a statically indeterminate systems. Now remember this in a nutshell. If there is a system having 2 or more members having different materials, using equation of statics alone is not enough. It has to be supplemented with these equations which connect load with the deformations. Such systems are known as statically indeterminate systems. That's it. Now in that quest, let us take up this problem and let's see what it has got. Okay. So this figure has already been given to you, and let me just read out the problem description. Here we go. So we've got 3 equally spaced rods, 3 rods, 1, 2 and 3. Okay. On a vertical plane, obviously you can see that, which support a rigid bar. Rather you can say a rigid bar is suspended. This rigid bar AB is suspended from these rods, you can say. Okay. Support is not the right word, I guess. Anyway, there are 2 outer rods, the material of which is brass. Their diameters have been given to you, 25 mm. Okay. And here also the diameter is 25. Actually, the real figure looks something like this. Let me just draw it, and I'm pretty much sure that you'll understand it very well. The real figure is something like this. There are 3 rods over here. This one is the bigger rod. These are the 2 smaller rods, isn't it? These 2 rods are of brass and this one is of steel. So this diameter has been given of brass. How much? 25. So I've written it over here. So this is the cross section area, you can say. Okay. Actually it is looking like that. Secondly, the length of steel and the diameter of steel rod also has been given. How much? The length is 800 and the diameter is 30 millimeters. So I've written it over here. That's the length of steel rod. That's the diameter of the cross section. And similarly, we have got the data for brass rod also. Now, what are we supposed to do? Look, we have to determine the forces in the bars. So the force acting along this rod is, let's say, PB, and acting along this rod, let's say, is PS. What we are supposed to find is the force acting along brass, PB, and also acting along steel, that is PS. So these are the 2 unknown values which you need to work out. Okay, and equation of statics alone is not going to help you. You have to take into account the factor of deformation also. I'll let you know all of those things. Don't worry, keep watching. And it's better that if you can just pick up a pen, piece of paper, and also a calculator. That is also going to help you. Okay, so try to solve this problem simultaneously with me. Okay, now then there is this force acting 120 kilonewton through the midpoint of the bar. through the midpoint of the bar, there is this force acting. The magnitude is 120 kilonewton. Anything else? The bar remains horizontal. Okay, the bar remains horizontal after application of load. Take ES over EB and refer to the figure. Right. Let's say after application of load, the bar reaches this position. In that case, the bar must have traveled a certain amount of distance, isn't it? This is the deflection in the bar. Right? Obviously, brass would have extended, steel also would have extended, and there is one very important term which is it stays horizontal. Even after the application of load, the bar stays horizontal. That means the deflection in brass is equal to the deflection in steel. This is really going to help us. Deflection in brass is equal to the deflection in steel. And let's try to frame a formula. And I'm pretty much sure that if you have been watching my previous videos, change in length, increase in length or decrease in length is given by PL over AE. So for steel, we have something like this. For brass, let's say PB, LB, AB, EB. Similarly, here PS, LS, AS, ES. Now just try to write PB in terms of PS and we have something like it. So LS over LB, LS over LB multiplied by AB multiplied by EB and AB by AS and EB by ES. There you go. Now you need to punch in all the values. Once you do so, you will have a relationship between PB and PS. So it's something like this. Watch this. Here we go. Let's do it here. So we have PB. PB is equal to, let me punch in all the values. LS over LB, steel by brass. Steel by brass 800 by 600. 800 by 600 multiplied by the area, brass divided by steel. So area is basically given by pi by 4 d square. It is the cross sectional area that we are talking about. And diameter for, if you want to find the cross section area for brass, put the value of diameter for a brass over here, and similarly when you put the value of steel's diameter, you get the value of cross section for steel. So AB over AS, it's going to be something like this, pi by 4 d square. What's d? D for brass. D for brass is how much? 25. So you need to punch in 25 square, and this is going to be pi by 4 into, for steel it is 30 square, multiplied by finally EB over ES. We have a relationship. ES over EB is equal to 2. So opposite, reciprocal, EB over ES will be 1 by 2. Okay. On solving this, punch this into a calculator and you will have a relationship like this. PS is equal to 25 by 54 PB. And let's say this is our equation number 1. Let me just go ahead and check this. 25 over 54 times of, this is PB is equal to this much times of PS, right? Now how to frame another equation, because we are having two unknowns, so we need to have two equations. The second equation can be obtained using the free body diagram. Let me just show you free body diagram. Free body diagram of bar AB. So watch this carefully. It's like this. This is bar AB. Obviously the load acting in the downward direction, that is 120 kilonewton. Now there is going to be some resistance offered from these bars. So there are two brass bars and one steel bar. So it's going to be something like this in the upward direction. Here also and here. That's brass. Okay, outer rod are of brass and middle one is steel. So that's pretty simple. All of the forces acting in the upward direction is equal to the force in the downward direction. Or you can also say summation of all the forces acting along y is equal to 0. In that case you have PB plus PS plus PB is equal to 120. You can also write 2 times of PB plus PS is equal to 120. So you need to plug in the value of PB. PB is equal to what? This 25 by 54 times of PS. Once you do that, plus PS is equal to what? 120. You just need to take PS as common. The stuff remaining inside would be 25 twice is 50 over 54 plus 1, and that's equal to 120. This is very simple. PS will be equal to 120 multiplied by, so the LCM obviously is 54, shifts, that's 54 whole divided by 54 plus 50 is 104. This is very basic. So the value of PS is going to work out as, let me check, PS is going to work out as 62.3 kilonewtons. 62.3 kilonewtons, and when you punch this value over here, that is multiplied with 25 over 54, you are going to get the corresponding value for PB, which is going to be equal to 28.8 kilonewtons. It's that simple. Now let us take a look at the second problem. So guys, now let us take a look at another problem. This is sort of based on a composite section. The material is same for both the members. The material is same. Now let me just explain you the arrangement. So this is suspended onto a ceiling, you can say, and this member 2 is or lies at a height of 0.8 millimeter above the ground. Okay, what happens when you apply a force of 40 kilonewtons? Obviously, this member will be under tension, and after a certain point in time, this member 2 will come into contact with ground, and then you can say that this member will be under compression. That's for sure. Now guys, one thing is for sure is that the net deflection, total deflection, delta L net, let me just write this, delta L net will be equal to 0.8 millimeters. That is for sure. But at the same time, you must not forget this, that this member will be under tension, a positive deformation, this member will be under compression, a negative deformation. And let me just give you a very good deep analysis as to why this member is under tension and why this is under compression, right? So what are we going to do? We are going to be making a free body diagram. Let's see how that works out. So we have it something like this. This is the upper member, by the way, and here let's make the bottom member. If you watch carefully, when this comes into contact with the ground, there is going to be a force offered from this ground. Let's say this is on member 2, let's call it R2. At the same time, there is also going to be a force offered from this support onto this member 1, that is in the form of R1. You can also say that R1 and R2 are acting in the upward direction. So positive, okay, 40 kilonewtons, this over here is acting in the downward direction, minus 40 is equal to what? 0. So you can also frame an equation that R1 plus R2 will be equal to 40, and this is in kilonewtons, by the way. You have to remember, everything that we are going to be doing in this problem will be in Newton and millimeters. Remember this, right? What's next? So what's this? This is how much? That's R2, isn't it? So in order to balance this R2, I'll have another force of this nature. Okay, so in order to maintain the equilibrium, I have an R2 over here also. Done. Bottom, top, same magnitude, makes no difference into the equilibrium of the system. If you watch carefully at this cross section, we also have a force of 40 kilonewton. Where? In the downward direction. And you can clearly see this 40 kilonewton will be split up into R2 and R1. That means who is dominating? 40 kilonewton is the bigger force that is dominating. So 40 is in the downward direction and this R2 is in the upward direction. So what we can do is, we can have one single force, okay, in the downward direction or in the direction of 40, you can say, and I can write this as 40 minus what? R2. And here we know very well the force acting is what? R1. And if you try to work out, this R1 will work out as 40 minus R2, something which we have already seen. R1 which is equal to 40 minus R2. One more thing that some of you guys might be wondering as to what is this 160 mm square, what is this 80 mm square. So these are bars. Let's say these are circular bars. So the actual arrangement is something like this. Let me just show you. Actual arrangement is something like this. Okay, something of this sort. The cross section that they are talking about is this. This cross section is how much? That is 80 mm square. We don't need the diameter. We already have the area. And the cross section over here, let's say, that is 160 mm square. Okay, so don't worry. The section could have been in this manner also. Let me just show you. It could have been in this manner also. Like this. It could have been in this manner also. Okay, then this would have been 80 and this would have been 160. Not to worry. You just need the magnitude of cross section area. Don't worry. How does it look in geometry? Don't worry. Now what? Now guys, if you watch carefully, the total deformation, the total elongation taking place is going to be equal to 0.8 millimeters. That is for sure. And we also know that this member 1 will be under tension. That means a positive deformation. The length is going to increase. And this member, that is member 2, since this is under compression, it will undergo a negative deformation. The length is going to decrease. How can I frame an equation? I can write it like this: delta L1 and delta L2. Delta L1, what is happening? Tension is happening, positive deformation, a plus sign you need to do. Delta L2, what is happening? Compression, negative sign. So you need to put a negative sign over here, and all of this. Okay, somewhere tension is happening, somewhere compression. The net deflection will be equal to, it's bound to be equal to 0.8 millimeters. 0.8 millimeters. It cannot go beyond that. Okay. Now, we have this Superman formula. What? Delta L is equal to PL over AE, and we are going to be using this formula. How can that be done? So, watch carefully guys. So, this is going to be for member 1, P1 L1 A1 into E minus P2 L2 A2 into E. You just need to plug in the values. Once you do that, you just need to solve this equation to get the final values. It's going to be that simple. Let me just show you how that's done. So E can be taken as common. I'll take E as common. Okay, 1 by E. The value of E is 205 gigapascal. So E has to be written over here. I'll write this E in Newton per millimeter square. So this is going to be equal to what? Watch this. 205,000 Newton per millimeter square. Do the conversion. You are going to end up here. 205,000. Let me just check. 205,000. Yes, it is. Okay. What else? So that's 205,000. Okay. So the stuff inside. P1. Where is P1? That's P1 for you. These two fellows are P2 and these two fellows are P1. The force acting along member 1 is P1, which is equal to 40 minus R2. Force acting along member 2 is R2. So that's simple. So the value of P1 is how much? 40 minus R2. Not 40, but 40,000. Okay, in newtons. 40,000 minus R2. Okay. Multiplied by length, this length over here. We have already written this P1. How much is the length of member 1? This is 1.2 meters. This can also be written as, if you multiply this by 1000, you will have the corresponding value in millimeters. So that is going to be multiplied with 1200. So we have P into L over E. A. What's A? A for you is 80 millimeter square. Let's move ahead. Plus. Now we have something else. P2. What's P2? Where is P2? Here it is. P2 is R2. Fine. So let me just write R2 over here multiplied by L2. L2 is 2.4. That is 2400 millimeters. 2400 divided by area 2. Area 2 is 160. 160, and that's it. All of this is going to be equal to what? All of this. Okay, this is not plus, this is negative. All of this is going to be equal to, let me just write it over here, 0.8 millimeters, and here also 0.8 millimeters. So guys, this is exactly how the equation has to be framed. This is very, very simple, very, very basic. One equation and one unknown in the form of R2. You just have to solve this equation. It's very, very basic. The final value of R2 that you are going to get, R2 will be equal to, let me just check. R2, by the way, there is no need of writing this square. Okay. The final value of R2 that we'll get is equal to 145.33.33. 145.33.33 in newtons. And when you put this value over here, you are going to get the corresponding value of R1. R1 will work out as, let me check. This is going to be 254.6. That is 254.66.67 newtons. So these can be converted in what? In kilonewtons also. So you can write this as 145.3 kilonewton, and you can write this as 254.6 kilonewtons. That can be done very easily. Okay. And then in the second part, we need to find the stresses in the bars. So that is also fairly simple. Let me show it here. The stresses in bar 1, the force acting is what? R1. Okay. R1 is equal to what? The force acting is this P1. You can say this P1 over area 1. And when you put the value of P1, what is P1? That is 40 minus R2. That is in fact R1 only. Okay, don't worry. That is in fact R1. P1 is R1. Let me just write this. R1 over A1. So R1 is how much? Let me just see. 254.66.67. 254.66.67 divided by area 1. Area 1 is 80. You are going to get the corresponding value in Newton per millimeter square. Similarly, you will have the value of sigma 2. That is P2 over A2. P2 is same as R2 over A2. Once you punch in the value, R2 145.33. 145.33.33 divided by, this is 160. You will have the corresponding value in Newton per mm square. And on calculation, this is going to work out as 318.3. Okay, this is Newton per millimeter square, and this is going to work out as 90.83. 90.83 Newton per millimeter square. Okay, so guys, that was all for today. We'll be taking some more problems from statically indeterminate system. Precisely, I've planned 4 to 5 more problems for you all, and then we'll talk about what do you call problems based on strains and Poisson's ratio and calculation of different moduli. So that was all for today. I'll see you again in the next video. Until then, take care and have a nice day. Thanks.